example of a physics problem that we're going to do, taking advantage of this way that we have of describing vectors. In this case, they're going to be forces in two-dimensional space, if we know the magnitude of the vector or the force and the angle that it makes with the positive x-axis. Okay. Now, a lot of the examples that we do in this class are going to be physics examples. I do not expect you to know any physics coming into this class. I fully recognize that some of you know more physics than I do. So there are going to be very different backgrounds. Some of you have taken multiple physics classes, some of you have taken none. Okay? So the only physics you're responsible for in this class is the physics that we cover together. For some of you, it's going to be familiar, but you're maybe using slightly different notation or approaching problems a slightly different way because we're going to be using the techniques of vector calculus. But if you don't know any physics, don't panic when you see that we're looking at a physics example. Okay. So here, we're asked to find, we've got this object that weighs 150 pounds, and it's suspended from these two cables. So one cable up here that makes an angle of 45 degrees with the ceiling, and one cable here that makes an angle of 30 degrees with the ceiling. And we are supposing that the object is not moving, okay? So that it's hanging from the ceiling in such a way that it's in what we call static equilibrium. So nothing is moving because all the forces cancel each other out. And in this case, there would actually be three forces. There's the force in this cable. When a force is in a cable that's holding something up, we call that a tension. So I'm going to just draw that in as a vector, and I'm going to call that T1. That's the tension in the first cable. Now, since that's holding the object up, it's got to be acting up. So you'll notice I drew it acting up. I didn't draw it pointing down because it's not causing the object to move down. That's supporting the object, holding it up. Similarly, this cable is going to have a tension that's also acting upward. So it's going to be holding the object up. And then here, the weight of an object is a force. Weight is the force of gravity acting on an object. So I'm going to just draw in, I'm going to call that F, which is the force of gravity. Now that's acting down. Gravity always acts down. Okay? I can actually calculate exactly what this vector is then. It's going to be 0, negative 150. Pounds are a unit of force. Okay? All right, and since gravity acts down, it has no left or right component, but it acts straight down, so it's got a negative component, but the magnitude is equal to the weight of the object. Okay, excellent. So I want to now find the tensions or the forces. So I want to find these two vectors. Okay. Notice that the magnitudes of these two vectors is not going to be the same as the length of the cable. Okay. It's the length of the vector that I'm looking for, which is the magnitude of the force. Okay. So don't confuse the length of the cable with the amount of force that the cable is adding to this system. Okay. But basically, I know that if the object isn't moving, that T1 plus T2 plus F has to equal 0. Okay? That the net force, the resultant force, when I combine all three of these forces, the two things that are holding it up and the one force that's bringing it down, gravity, I'm going to end up with a net result of 0. So I want to try to describe T1 and T2. What I'm going to do is I'm going to let T1 without the bar over it represent the magnitude of the vector T1. Okay. This is often done in physics, that you can take the name of the vector, and if you drop the bar, often physicists will use that as the notation for the magnitude. That's not something that we'll do in general this semester. If I want to write magnitude in general, I'll write this. But I can, for a particular problem where I know I'm going to be using that multiple times and it might get a little unwieldy to write this, I can, as long as I identify it, say for this problem, I'm going to use that physics notation, that I'm going to just let the name of the vector without the bar over it represent the magnitude of that. Because now I can write T1, the vector, in terms of two things. Its magnitude, which I'm calling T1, and the angle it makes with the positive x-axis. Now I just have to be careful here because it doesn't make a 45-degree angle with the positive x-axis. Essentially, what I've done here is I've put all of the forces here. So if I want to, I can think of my axes as being here. So here's the positive x-axis. That's the angle that we make with the positive x-axis. So that's going to be 90 degrees plus, that's a perpendicular. This would be another 45-degree angle as well. So that's going to be 135 degrees. So T1 is going to be T1 copies of cosine of 135 degrees, sine of 135 degrees. So that's going to be, well, I'll do two things. I'm going to do the scalar multiplication, and I'm going to evaluate the sine and cosine. So cosine of 135 is negative cosine of 45, so I'm going to get negative 2t1 over root 2. Okay. And sine is positive cosine of the reference angle, which would be 45. So that's going to be, oops, I wrote 2 over root 2. I meant to write root 2 over 2. I apologize. So sine would be root 2 over 2, but I'm multiplying that by t1 as well. So I've done the scalar multiplication and evaluated the sine and cosine. Okay. Notice I can do a quick double check. T1 is pointing left and up. So I should have a negative component for the x component and a positive component for the y component. If you just work with 45 degrees, you're going to have them both positive, and you would have a vector that was pointing up and to the right instead of up and to the left. Okay, T2 I can do very similarly. I can say the vector T2 is just going to be the magnitude, which we're writing as T2 without the bar, times, let's see what this angle is. Now here, this line which I've drawn in as the positive x-axis is parallel to the ceiling here. So this is also going to be a 30-degree angle right here. So in this case, this angle matches this angle. That is the angle we make with the positive x-axis. So we're going to have cosine of 30 degrees, comma, sine of 30 degrees. So we'll have, let's see, cosine of 30 is root 3 over 2. So we'll have root 3 over 2 times T2, comma, sine of 30 is 1/2, so we'll just have T2 over 2. Excellent. So now I can write in describing all of my vectors component-wise. Now with these two vectors, I've introduced two unknowns. I've introduced T1 and T2 without the bars, which are the magnitudes of these two vectors. Okay, so I've got two unknowns going on here, but let's just see what happens. T1, we said, was negative root 2 over 2 times T1, comma, root 2 over 2 times T1. Plus T2, we said, was root 3 over 2 T2, comma, 1/2 T2. I'm going to erase this work here just so I get a little bit more space. F, we said, was 0, negative 150, and that's got to equal 0, 0. So I have this one vector equation. But since it's a vector equation in 2 space, I know that this vector is equal to this vector if and only if they have the same x component and the same y component. So that's going to give me 2 real valued equations. I'm going to have a system of 2 equations in 2 unknowns, where the 2 unknowns are the magnitudes T1 and T2. So if I look at just the x component, the x component here is negative root 2 over 2 T1, plus the x component here is root 3 over 2 T2, plus the x component here is just 0, and that's got to equal the x component here, which is 0. So that's one equation in my 2 unknowns, which were the magnitudes of these 2 vectors. If I look at the y components, those have to be equal. So So the y component here was root 2 over 2t1, plus the y component here was 1/2 t2, plus the y component here was negative 150, and that's also got to equal 0. So now I've got just a system of equations, 2 equations, 2 unknowns, should be able to solve this. So I'm going to solve for the 2 unknowns. Do be careful, that just gives me the magnitudes. Don't forget that we were looking for the forces, which are vectors. So once I have the magnitudes, I need to plug those in to get the vectors T1 and T2 with the bars over them. Okay, I'm going to go ahead and work this out, but I would suggest that you go ahead and pause the video, work this out for yourself, and then just double check your answer. Okay. All right, I think what I would probably do in working this out is add this over. So I would have root 3 over 2t2 is equal to root 2 over 2t1. And then I can just do a nice substitution. I'm going to solve for one of these in terms of the other. I can say t2 is 2 over root 3 times root 2 over 2t1. So t2 is just root 2 over root 3 times t1. Now I can substitute that in to this equation. So I'll have root 2 over 2t1 plus 1/2 of t2, which is root 2 over root 3 times t1. And I'm just going to say that equals 150. So I'm going to just add the 150 over to this side. So now I can factor out the t1. So t1 times root 2 over 2 plus root 2 over 2 root 3 is equal to 150. T1 is going to equal 150 over root 2 over 2 plus root 2 over 2 root 3. That's a little bit messy. Not crazy about having complex fractions, so I'm going to do a little bit of simplifying here. I think if I say this is 150 over, I'm just going to get a common denominator of 2 root 3 over 2 root 3, or sorry, 2 root 3 here. So that means I just need to multiply this one by root 3 over root 3. Okay. So then that becomes root 6 plus root 2 all over 2 root 3. But when I divide by a fraction, I multiply by the reciprocal. So I'm going to have 150 times 2 root 3 over root 6 plus root 2. Okay, let's see. That's going to be 300 root 3 over root 6 plus root 2. Okay, so we have solved for t1, the magnitude of the vector t1, and that is 300 root 3 over root 6 plus root 2. Now, obviously, I can simplify that a little bit more if I wanted to. I don't want to spend a lot of time just working out that algebra. I wasn't crazy about having complex fractions, so I decided to simplify things further. On exams, the directions will always say simplify to the extent that we have in class. Okay. I might say, if I didn't say anything further, you could stop at this point, but I might say don't involve complex fractions. So then I would expect you to get rid of the complex fraction. Okay. And I don't expect you to be a mind reader. So as we work through these problems, I try to sort of establish how far I would usually simplify things. And so you'll have some sense of what to expect going into exam. But as you're taking an exam, if you're not sure whether you need to simplify more, that is always something that you can ask. So while you're taking your exam, you're not allowed to use your phone during exams, except to call me. But you can use your phone to call me and say, hey, do I need to simplify this further? That's perfectly acceptable. Okay. So I'll try and make things as clear as I can by working through examples in class and by having verbal descriptions of how far I expect you to simplify if I anticipate there are going to be questions, but you're always allowed to ask. Okay, excellent. So I've got T1. Let's get T2 the number, and then we'll get T1 and T2 the vectors. Okay, So we said T2, the number, was just root 2 over root 3 times T1. So now that's times 300 root 3 over root 6 plus root 2. Well, that's nice. The root 3's cancel. And so I'm going to have 300 root 2 over root 6 plus root 2. Again, that could be simplified more. That's as far as I'm going to go. And then we can say T1, the vector. Let me just remind us that that was negative root 2 over 2 times T1, comma, positive root 2 over 2 times T1. But now I know what that magnitude is. So let's see. We're going to have negative root 2 over 2 times 300 root 3 over root 6 plus root 2, comma, root 2 over 2 times 300 root 3 over root 6 plus root 2. So let's see. That 2 is going to just cancel in both cases to make that a 150. So here I'm going to have negative root 6 over root 6 plus root 2. I'm sorry, negative 150 root 6. And here we'll have positive 150 root 6 over root 6 plus root 2. So there's the first tension, which is a vector. Remember, forces are vectors. If I ask for the amount of force, that would be asking for the magnitude of this. But if I ask for the force, a force is a vector. It has magnitude and direction. Okay. All right, and then T2, the vector, okay, remember was, let's see, root 3 over 2 times the magnitude, and then 1/2 times the magnitude. And now I'm plugging in the magnitude of T2, which is this number. So we're going to have root 3 over 2 times 300 root 2 over root 6 plus root 2, comma, 1/2 of 300 root 2 over root 6 plus root 2. And again, the 2's are going to cancel to give me a 150. So we will have 150 root 6 over root 6 plus root 2, comma, 150 root 2 over root 6 plus root 2. All right, so that's my T1, and that's my T2, the vectors that we have. So, somewhat tedious, okay? You'll notice I gave you fairly nice angles, and I did this all without a calculator. Just a reminder, you're not allowed calculators on an exam. So, as you're doing the homework, you're going to have some problems that don't have some nice angles. As you're doing the homework, you've got it. You're allowed to use a calculator, okay? But be prepared to work with nice angles. If the reference angle is 30, 60, or 45, I expect you to be able to work it out without a calculator.